Hello students, welcome to EPG Pashala. Today we will study about data structure in GIS. Particularly we will talk about and study about raster and vector data. I would like to inform and I would like to tell that data is very much important in GIS, and particularly when we talk about data structure in GIS, it is very much important to understand the concept of GIS, because without understanding the concept of GIS, it will be very difficult to understand what is data and what are the structures of data. And particularly when we talk about data, there are different types of structures in the data. So basically today what we will try to study is the concept of GIS, which will talk about various concepts and what are its application. And secondly, we will talk about the data types in GIS, because it is very much important that to understand the concept of GIS as well as the data structures. And third, we will talk about the spatial and non-spatial data, because without understanding the spatial and non-spatial data, it will be difficult to understand the data structures. And finally, we will try to talk about the process of GIS in map making, which will try to give more application study in the study of data structure in GIS, particularly when we try to talk about the vector and the raster data. What are the types of data used in GIS and what are the purpose of this data in GIS? It is very much important to understand, because without the concept of having this GIS or data structure, it will be very difficult to understand the concept, particularly when it comes to raster and vector data. As mentioned by Chorley report in 1987, GIS is a system for capturing, storing, checking, integrating, manipulating, analyzing and displaying data, which are spatially referenced to the earth. This is normally considered to involve to spatially reference computer database and appropriate application software. So when we try to talk about GIS, GIS is Geographic Information System, which can be defined as a set of computer-based integrated technology which provide tools to compute geographic data along with its various attributes like storage, retrieval, manipulation, analysis and display the finding. So the important function of GIS is data integration. And when we try to talk about the capability, the main capability is to establish relationship between geographical data and the attribute. There are three basic qualities of geographic information system. The first one is it creates one-to-one relationship between geographic features and their attribute on the map. What is geographic features and what is attribute? We will be discussing in the later stage of our presentation. And the second element, which is very much important, is the link between geographic features and its record is maintained via a unique numeric ID, which is assigned to its features in the data structures. The third and the most important is the ID of the feature is physically stored in two places, in the file that contains the XY coordinate pairs and with the corresponding record that is featured in the attribute table. Now let us come to the element of GIS, because this element of GIS is going to give us an information about the whole concept of GIS. So the important element of geographic information system are hardware, software, people, data and analysis. So it is a combined of different elements which produce a data or which constitute a data. It is a collection of hardware, and in the hardware it includes the system, and these systems are used to run sophisticated softwares, and this software will be used from a data which is procured, and the procedure and the instruction of user to compute, manage, manipulate, analyze and display the final analysis of the data. So when we come to the basic concept of GIS, we can summarize that it is an interdisciplinary science that has interrelationship with cartography, geography, photogrammetry, remote sensing, geodesy, surveying, statistics, computer science, mathematics, and civil engineering. Students, now let us study about the types of data. There are two types of data used in GIS platform. The first one is the spatial data. The second one is the non-spatial data. Let us first talk about what is a spatial data. Spatial data contains coordinates, that is latitudinal and longitudinal position of features. It represents the location of geographic entities together with their spatial dimensions. The spatial data are represented with the help of point, line, and polygon features. What are these point, line, and polygon features? We will discuss in the later stage of our presentation. The second one is non-spatial data. What is this non-spatial data? Non-spatial data, which is also known as attribute data, represent a set of information that is systematically organized and compute against each spatial data. For example, if the spatial data contains a polygon representing a state or a country, and its attribute data, it has information about administrative divisions, total area, population, and so on respectively. So if you see from the slide, the spatial data and non-spatial data are represented in point, line, and polygon, and whereas the non-spatial data are represented in the attribute table. Students, let us now talk about the spatial data and non-spatial data in detail. Let us first talk about what is a non-spatial data. Non-spatial data are of two types. The first one is statistical, which has a numerical value, and number two is the descriptive, which has a word or text. As you can see from the table given below, there are numeric as well as word or text in the attribute table. Now let us talk about the spatial data. The spatial data are of two types. One is raster data and the second one is the vector data. And today the main discussion or the main study of the presentation is on raster data and the vector data. Now coming up to the raster structures. Raster data comes in the form of individual pixel. It is represented as matrix, grid of pixel. Each pixel represents locational information. This type of spatial data is usually bulky and required large storage capacity. Example of raster data are satellite imagery, digital elevation model, which is also known as DEM, aerial photography, and scan map, etc. All pixels in a raster data must be the same size, determining the resolution. The pixel can be of any size, but they should be small enough to perform maximum detail analysis. The pixel or cell can represent a square kilometer, a square meter, or even a square centimeter. So it is very much important to understand what is the size of the pixel, which can vary from small to very large, and which represent a particular area, which can be small, very small of square centimeter, or which can be very large of square kilometer. Cell and pixel are arranged in rows and columns that construct a certain matrix format. And when we try to talk about a matrix format, the rows of matrix are parallel to x-axis of the Cartesian plane, and the columns are parallel to y-axis. Each and every pixel or cell has a specific row and column addressed to the particular features. Regarding the satellite images, the basic characteristic of raster data structure are: number one is area is covered by grid, which is usually equal sized and extend in rows and column. Number two is its pixel is assumed to have an only one value, called the DN value, which is a digital number value, but in some cases it becomes inaccurate. As for if boundary of two soil types come under or run across the middle of the pixel, in such case the pixel is assigned the value of largest fraction of the cell or the value of the middle point of the cell, which means that if any boundary or if any line if goes through the middle part or any part of the cell, that means the larger fraction will be counted to represent the features. Cell often called are pixel. To represent a land cover, this pixel creates metric format. The x and y value of the pixel usually represent the pixel size, that is the spatial resolution of the pixel. Therefore, when we calculate the area with the help of the pixel, it is calculated as the area is equal to count multiplied by x and y, where the count is total number of pixel in one class or total number of pixel having some digital number value. And what is the grid? Grid often has its origin in the upper left, but latitude and longitudinal value compute the center of the grid. Now coming up to the vector data structures. What is a vector data structure? Vector data comes in the form of point, line and polygon. It records spatial information as x and y coordination. In general, vector data structures produce small size than raster data structures. Beside the size issue, vector data is easier to handle than raster data. Its structure is simple and it is more flexible to be adjusted for different scale. For example, a projection system in a mapping application. This makes vector data structures the apparent choice for most mapping in GIS. There are three ways of vector data representation having three different structures: point, line and polygon features. Now what are the features? Let us try to look into detail of it. Point features has a zero dimension because it represents neither length nor width nor breadth. So it is represented by single x and y coordinate. It has area size 0, mostly used to denote a single particular features or a particular area or a particular location of a particular features. Number 2 is the line features. It has only one dimension which can represent the length of a particular features, represented by connecting two or more pairs of x and y coordinate. It has its length value commonly used to demarcate road, river, streams and so on. So considering the fact that the representation of features in line has more dimension than the point features. The third is the polygon features. It has two-dimensional which can represent both the length as well as the width of a particular features. It is represented by connecting 4 or more pairs of x and y coordinate. The starting point should be the ending point. It preserves an area in the form of demarcation features which has a closed boundary, for example like a field or a campus or a particular administrative boundary of a particular place. Vector data structure maintained the geometrical and mathematical relationship between the associated features. As you can see from the diagram that a point and line and polygon, the features representing various structures of a particular features. Topology among geometrical object or item are much easier to be represented using vector data structures, since a commonly shared edge can be easily defined according to its left and right side polygon. Now when we try to talk about a vector data structures, it is very much important to talk about a particular features called as TIN, Triangulated Irregular Network Surface. What is this TIN? It is a vector data structures that represent the Earth surface as contiguous non-overlapping triangles. Within each triangle, the surface is read by a plane. The triangles are formed by a set of points that are called as a mass point. It is a three-dimensional way to represent the homogeneous Earth surface, because when we try to talk about the Earth surface, there are different kind of features. So these features can be accurately represented in the form of TIN, which is triangulated irregular network surface. In a triangulated irregular network model, the world is represented as a network of linkage triangles drawn between irregularly spaced points with x, y, and z value. Now y represent and x represent and z represents the longitudinal, latitudinal, and elevation value. TIN are an efficient way to store and analyze surface. Heterogeneous surface that vary sharply in some areas and less in other can be modeled more accurately in a given volume of data with a triangulated surface than with a raster. This is because many points can be placed where the surface is highly valuable and fewer points can be placed where the surface is variable. Students, let us now look into the file format of raster and vector. First, let us look into the rasters. In a raster data structures, georeferencing information required to display with the image or the scan map. It requires an accompanying world file to store the location information. Some of the important raster file format are image, which is TIFF, bitmap, BIL, and JPEG. In image file, we can see that it is image.tiff, image.bmp, image.bil, image.jpg, and in world file we can see that it is being coded as image.tfw, image.bpw, image.blw, image.jpw. Here a point to be noted that GeoTIFF is a single file format that preserves both image and world information in a single file. However, TIFF and GeoTIFF most commonly used in a raster file format. Now let us look into the vector file format. In vector data structure, there are two types of file format. Number one is the shape file and number two is the geodatabase. Now when we look into the geodatabase are also divided in two types, that is file geodatabase and personal geodatabase. And here a point to be noted is that the geodatabase has more storage capacity than the shape file. It also can create topology that removes the geometrical errors between the associated features in the map. In the large scale mapping, geodatabase is more preferred than shapefile so that it can store more attributes. Now students, let us look into the advantage and disadvantage of raster and vector data structures. Now when we look into the raster data structures, the basic element is the extent, which is the rows and the column, the origin and orientation, the resolution, which is the pixel, and the grid cell, which is very much element of the raster data structures. And when we look into the advantage of raster data structures, number one is it is a very simple data structures. Overlay and combination of map and remote sense image are very easy in raster data. Some spatial analysis methods are very simple to perform. Stimulation is very easy because the cell have same size and shape, and technology is both manual and digital. But when we look into the disadvantage of raster data structures, the use of large cell to reduce data volumes means that phenomenologically recognizable structures can be lost and there can be a serious loss of information. Crude raster maps are considerably less beautiful than line maps, and network linkage are difficult to establish. The projection, transformation are time consuming unless spatial algorithm or hardware is used in the vector data structures. Now let us look into the vector data. The basic element of a vector data structure is location, which can be represented as xy value or xyz value, which is the latitudinal, longitudinal and elevation. Explicit, that is pegged to a coordinate system. Different coordinate system and precision requires different value. For example, UTM as integers. Latitude and longitude are two floating point numbers. Points are used to build more complex features. If we look into the advantages of vector data structures, number one is it has a good representation of phenomenology, compact, topology can be completely described, accurate graphics, retrieval and updating and generalization of graphic and attribute are possible in vector data structures. And when we look into the disadvantages of vector data structures, a complex data structures. It is a very complex data structures. It has combination of several vector polygon map through overlay creates difficulties. Stimulation of difficult because each unit has a different topological form. Display and plotting can be expensive, particularly for high quality colors. The technology is very expensive, particularly for more sophisticated software and hardware. Spatial analysis and filtering within polygons are possible. Now students, let us look into the most important thing of GIS is the application. What are these applications? The application of GIS in mapping is very much important in terms of the processing of images. As we all know, geographic information system is basically a digital map making process. It is accompanied with remote sensing and GPS survey altogether, which is known as geoinformatics. During the process of map making, each and every kind of data types has its own importance and all are interlinked with each other to produce a complete map. How is raster data used in mapping is very much important. Let us look into the process of it. The raster data are primarily used as a base for the vector layer creation. It is used as the base for creating the vectors. After georeference, the raster data, it is taken as a first and primary layer for mapping. The raster data usually produced with the help of remote sensing technology, example satellite images, aerial photography, DEM. Also the scanned topographical maps primarily created by manual process are also used in creating the vector. Most popularly used raster data are satellite images, digital elevation model, scanned topographical map. And here a point is to be noted that georeferencing is a process to project the raster data in reference to real art so that one can integrate the locational information for each cell or pixel, georeference the data, the raster or verifying its projection, whether it is proper or not, is the basic of map making. Students, now let us look into the use of vector data in mapping. After taking the reference raster as a base, depending upon the purpose of mapper, the vector is created. And as we all know, in vector, number one thing is the point vector, which is mostly used to denote a single or specific features. It gives single locational information. It is a zero-dimensional vector layer. It has no area coverage or length coverage. The second is the line vector, basically used to demarcate one-dimensional features that preserved a specific length in reference to the real art. Mostly used for road network, streams, administrative boundaries. And the third is the polygon features, which is used to map out features that need to calculate its area coverage. It is two-dimensional vector layer having length and width. It can preserve the area coverage in extraction, in creation of line and polygon features. As for example, in mapping the big river, mapper mostly preferred polygon rather than line. On the other hand, triangulated irregular network TIN used to create when mapper need to show the undulation or irregularities of a particular study area in reference to the real art. Art surface is not perfectly homogeneous or a regular one. It has undulation, therefore elevation of each part of art varies from one another. TIN is used to a three-dimensional model that can show length, width and height of the features. This particular vector layer creates preferably with the help of DAM, that is digital elevation model, that integrates the height of the fractures or heterogeneous art surfaced. A point to be noted here is that another important consideration is the projection system or reference system. Both for raster and vector layer must be the same, or it will show rectification error. The conversion of raster to vector structures and vector to raster data structure is done in some case when needed. However, conversion of vector to raster is more common and easier than raster to vector data. In some particular case, after processing of classifying the raster, it is used to convert to vector, but it is time consuming as well as not error free and need further processing to make it error free. Raster data like drainage network or ordering is not possible to convert to vector data structure directly. In some case, one again need to perform vectorization. Direct conversion of raster data structure to vector data structure is nearly impossible. Students, now let us look into how the attribute data is used in mapping. Attribute data are the information about the feature of the earth that can be statistical or description. It can be computed manually by the mapper or calculated with the help of respective software. This attribute data comes out as a tabular format. One can compute or generate as much as attribute accordingly depending upon the required information need to show the mapper. This attribute data layer also adapt and store the x and y coordinate information of the feature against which it is computing. Further, depending upon this attribute data, mapper can classify and categorize the vector layer as they want or need, applying different types of symbology, color, shades and so on. So it is now important to understand that GIS is different from other application. Now let us look into what are those things that make GIS different from various others application. The first thing is that it is a subset of information science that deals with spatially and geographically reference data. It is different from mapping computer air cartography because of its analytical capacity. It is different from CAD, that is computer aided design program, because it performs spatial operation and can maintain the geometrical relationship among the features. It is different from DBMS, database management system, because it has a cartographic interface. And the final one is geographic information system, use almost every kind of data structures that can digitally integrate and manipulate. So dear students, today we have discussed about the data structure in GIS and in this data structure in GIS, we have discussed and studied about the basic concept of GIS. And in this basic concept of GIS, we have studied about the element of GIS as well as the application of GIS in particularly in the process of map making. And next we have discussed about the data types in GIS. When we talk about data type in GIS, we have studied about the spatial data as well as the non-spatial data, whereas the non-spatial data comprises of numerical and the word or the text. And when we study about the spatial data, we talked about the vector data and the raster data, which was the main discussion of today's lecture. And in vector data and in raster data, we have studied about its advantages and disadvantages, and we have also studied about the point features and line features and polygon features. And we have also studied about the GIS as one of the important tools. Thank you.